AI seems like it's about ready to unlock just about anything these days, doesn't it? I mean, it can beat us at Go, write poetry, and even compose music that is almost indistinguishable from human-composed music.
Right, yeah.
So, of course, the big question is, will it be able to make groundbreaking scientific discoveries, the kind that rewrite textbooks,
Right.
the kind that win Nobel Prizes?
Yeah, that's the big question, isn't it? Like, can these AI systems actually come up with something truly original, something fundamentally new, from scratch, like we humans sometimes do?
Oh, right,
Like,
yeah.
not just building on what we already know, but pushing the boundaries of knowledge in ways we haven't even imagined yet.
Exactly. That's what we're diving into today. I found this super interesting article in Scientific Reports. It was published just last month in March 2025.
Okay.
And in it, some researchers put one of the most advanced generative AI systems out there, ChatGPT-4, to the test. They wanted to see if it could actually make a Nobel Prize-worthy scientific discovery. And they designed this really clever simulated experiment in the field of molecular genetics to do just that.
So they basically created a little scientific mystery for ChatGPT-4 to solve.
Yeah, exactly. And so what we're going to do in this deep dive is really unpack this whole experiment, We'll look at what ChatGPT-4 was able to do, what it struggled with, and how that compares to how human scientists approach these kinds of problems.
I like it.
So let's break it down. What exactly was this Nobel-worthy problem that they gave to this AI?
Well, they took inspiration from the work of these two scientists, Jacques Monod and Francois Jacob. They actually won the Nobel Prize back in 1965 for their discoveries about how genes are controlled in bacteria.
I see.
So to make it something that ChatGPT-4 could work with, the researchers simplified this down to a very specific case study within E. coli bacteria. And they focused on how certain genes in E. coli regulate the activity of other genes, kind of like chain of command within the DNA.
Oh, interesting. A chain of command.
Yeah. So there were these 3 regulatory genes involved, which they labeled P, I, and O.
Okay.
And then there were genes that are responsible for producing a specific enzyme called BACAL.
Got it.
ChatGPT-4's task was to figure out the exact roles of these regulatory genes, P, I, and O, in controlling the production of BACAL.
Okay, I'm following. So they basically gave this AI a mini genetic puzzle to solve.
Exactly. It had to determine, for example, that the I gene acts as an inhibitor, but it does so through a chemical interaction, while the O gene also inhibits, but it does so physically, like blocking the process in a different way.
Oh, wow, that's fascinating.
And then there's the P gene, which it had to discover plays no role in this particular system.
That's pretty clever. But how could ChatGPT-4 actually conduct experiments? I mean, it's not like it has hands to work in a lab, right?
That's right. It can't physically manipulate things in a lab. So to get around this, the researchers created this really cool thing they called SANGMEL that stands for Semi-Automated Molecular Genetic Laboratory.
SANGL.
It's basically a sophisticated computer simulation that allowed ChatGPT-4 to, quote-unquote, run experiments in a virtual lab setting.
Oh, that's a clever workaround.
Yeah. So instead of physically mixing chemicals or growing bacteria, the AI would propose an experiment, like let's say using a particular strain of E. coli with a certain gene knocked out, or maybe adding a specific chemical to the mix. And then the researchers would take these instructions, feed them into the SAMGL software, see what happens in the simulation.
I see.
And then, crucially, they'd give those results back to ChatGPT-4. So it was this really neat back and forth between the AI designing experiments.
Oh, that's cool.
And the humans actually carrying them out, but all within this virtual environment.
I love it. It's like they gave ChatGPT-4 its own digital playground for science.
Right, exactly. But to really see how well ChatGPT-4 was doing, they needed to compare its performance to something. Right?
Yeah, they needed like a baseline.
Exactly. So they compared ChatGPT-4's performance with data from a previous study where they had actual human subjects tackle the exact same genetic puzzle using this AMGL system.
Oh, that's really smart.
But here's the key difference. With the human participants, they also had them do something called think aloud protocols.
Think aloud protocols, what are those?
So basically, as the human subjects were working through the problem, they had to verbalize everything they were thinking, like their hypotheses, their experimental plans, their reasoning, their doubts, everything.
Oh, that's really interesting. So they're basically capturing the whole thought process, not just the final outcome.
Exactly. And this gave the researchers this incredibly rich data set about how humans actually think and reason through a scientific problem.
Wow.
Which is crucial if you want to understand how an AI's approach might be similar or different.
I see. So we've got our AI scientists designing experiments in its little virtual lab.
Right.
And we've got human scientists doing the same thing, but they're also talking us through their entire thought process.
Exactly. So let's dive into how ChatGPT-4 actually went about trying to solve this puzzle. Where did it even begin?
Yeah, how did it approach the problem?
Well, the first thing ChatGPT-4 did was generate hypotheses.
Oh, okay. Makes sense.
But instead of coming up with just one hypothesis, it proposed 5 different hypotheses right off the bat.
5? Wow, that's a lot to juggle right from the start.
Yeah, it's interesting, right? And the study found that these initial hypotheses were very heavily influenced by the knowledge that ChatGPT-4 already had.
Oh, so it was drawing on its existing database of information.
Exactly. Because the task involved E. coli and gene regulation, it immediately thought of this really well-known model called the lac operon.
Lac operon.
Yeah, the lac operon is like a classic textbook example of how E. coli regulates its use of lactose. And ChatGPT-4 seemed to be using that model as a kind of template or analogy for tackling this new problem.
Oh, so it was kind of like, I've seen something like this before. Maybe it works the same way here.
Yeah, that's a good way to put it. And the researchers noted that ChatGPT-4 was very confident in these initial hypotheses, even though it had just started the investigation.
So it's kind of like jumping to conclusions a bit.
Maybe a little. But it's important to remember that AI systems like ChatGPT-4 are designed to work with massive amounts of data.
Right.
So it's natural for them to try to connect new information to what they already know. But the key takeaway here is that it was relying more on recall than true discovery at this stage.
Okay, that makes sense. So how did the human scientists' approach to generating hypotheses compare to ChatGPT-4's?
Well, the humans, on average, proposed 14 hypotheses, which is significantly more than ChatGPT-4's 5.
Almost 3 times as many. So they were considering a lot more possibilities.
Yeah, they were definitely casting a wider net.
Right.
And what's even more interesting is that they came up with a greater variety of relevant hypotheses. The study actually measured this, and they found that the human subjects proposed an average of 7.78 different types of hypotheses.
Okay.
Compared to only 2 types from ChatGPT-4.
So the humans were exploring a much broader landscape of potential explanations.
Yeah, exactly. And this is really important because in scientific discovery, you often have to be willing to entertain multiple possibilities, even some that might seem a bit far-fetched at first.
Right.
Because sometimes those seemingly crazy ideas can lead to the most groundbreaking insights.
That makes sense. Now, after generating hypotheses, the next step is obviously to design experiments to test them. So how did ChatGPT-4 go about doing that?
Well, similar to its approach with hypotheses, ChatGPT-4 proposed all 12 of its experiments simultaneously right at the beginning.
Oh, wow. So it had a whole plan laid out in advance.
Yeah, it did. And while it did focus on the role of lactose in E. coli regulation, the researchers pointed out that this focus might have been a bit of a detour from the core objective of understanding how these specific genes controlled each other.
So it was kind of getting sidetracked by a related but not entirely central aspect of the problem.
It seems that way, yeah.
Interesting.
And another thing they noticed was that in its experiments, ChatGPT-4 mainly used just 2 levels of lactose. Either it was completely absent or it was present at one specific concentration. But the human scientists were much more experimental in their approach.
Okay.
They tried out various amounts of lactose to see if different concentrations would lead to different effects.
So it sounds like the humans were being more thorough and systematic in their exploration of the problem.
Yeah, exactly. They were really trying to map out the entire landscape of possibilities.
Right, right. Did that approach actually pay off for them? Like, did the data show that they were exploring a wider range of experimental options?
It did. The researchers actually measured something called the experimental space, which is essentially the number of different variables and combinations that were tested.
Okay.
And they found that ChatGPT-4 only explored a space of 8 dimensions.
8. Okay.
While the human subjects, on average, explored a space of 11.44 dimensions.
Oh, wow. That's a significant difference.
It is. And it suggests that the humans were casting a much wider net in terms of their experimental design.
Right.
And they also found that ChatGPT-4 proposed fewer of what they called key experiments.
Key experiments.
These are the experiments that are absolutely crucial for unlocking the core mechanisms at play.
Oh, I see. So they're like the linchpin experiments.
Exactly. ChatGPT-4 only proposed 4 key experiments, which was about 33% of its total experiments, whereas the humans proposed an average of 9.67 key experiments.
Wow.
Which made up almost 87% of their total experiments.
Okay, so even though ChatGPT-4 had this whole plan laid out in advance,
right,
It turns out the humans were much more effective at identifying and focusing on those really crucial experiments.
Yeah, it seems like they had a better intuition for where to dig deeper.
That's fascinating. Okay, so let's talk about what happened once the results started coming in from these virtual experiments. How did ChatGPT-4 interpret them?
Well, the study found that ChatGPT-4 was actually very good at summarizing the data from its experiments and using those results to justify its hypotheses.
Okay, so its analytical capabilities were strong.
Yeah, it was able to connect the dots between different experimental outcomes and relate them back to its initial ideas.
That makes sense.
But here's where things get really interesting. When the experimental results didn't actually support ChatGPT-4's hypotheses, it was much less likely to come up with alternative explanations or plan new experiments to further investigate.
So it wasn't very adaptable when faced with unexpected results.
It seems that way.
Okay.
And there's this one particular example that really highlights this. It had to do with the role of the P gene, remember?
Yeah, the one that they eventually discovered plays no role in this system.
Exactly. So the experimental data clearly showed that the P gene was not involved. But ChatGPT-4 stuck to its initial hypothesis about the P gene's role. It didn't revise its thinking, even though the evidence contradicted it. The researchers actually used the term stubbornness to describe this behavior.
Stubborn AI. That's kind of funny, but also a little bit unsettling.
Right. It's like it got fixated on its initial idea and couldn't let it go.
Yeah, I see what you mean.
And this is a key difference between how AI systems currently operate and how human scientists think. We're constantly questioning our assumptions and revising our models based on new evidence.
Yeah, that's what science is all about, right? Being open to being wrong and adjusting your thinking based on the data.
Exactly. And this adaptability is something that AI still seems to struggle with.
Okay, so ChatGPT-4 was a little bit stubborn. Was there anything else that stood out about its approach to interpreting the results?
Well, the researchers also noted that there were no real aha moments for ChatGPT-4.
Aha, moments.
Yeah, those moments where a scientist suddenly has a flash of insight or makes an unexpected connection.
Oh, I get it.
For ChatGPT-4, all of the results seemed to be kind of expected. It didn't show any signs of surprise or excitement when it encountered something unexpected in the data.
Oh, that's really interesting, because those aha moments are often what lead to those big breakthroughs in science.
Exactly. They're those moments where you suddenly see things in a new light and realize that your old way of thinking was wrong.
Right, right.
And those moments seem to be missing from the AI's process.
Okay, so to sum it up, ChatGPT-4 was a good analyst, but it wasn't very adaptable, and it didn't seem to experience those flashes of insight that are so crucial for human scientific discovery. So what was the final verdict? How did ChatGPT-4's discovery stack up against the human scientists?
Well, the researchers used a scoring system to evaluate how accurate each subject's final hypothesis was.
Okay.
And the scale ranged from 0 to 4.
Got it.
So ChatGPT-4 ended up with a score of 1.
1, okay.
Whereas the human subjects averaged a score of 1.67.
So the humans did better, but it doesn't sound like anyone got a perfect score?
That's right. And it's worth noting that this scoring system was specifically designed for this particular experiment, so it's not like a universal measure of scientific ability or anything like that.
Right, of course. But it does give us a way to compare the performance of the AI and the humans on this specific task.
Exactly. So let's break down what ChatGPT-4 actually got right and wrong.
Okay.
It did correctly identify the I gene as an inhibitor. However, it incorrectly determined the function of the O gene and the role of the P gene.
So it got some things right, but missed some key details?
Yeah, and most importantly, it failed to grasp the fundamental nature of the inhibition.
You mean the fact that the I gene works chemically and the O gene works physically?
Precisely. Some of the human subjects were able to correctly identify all aspects of the genetic control mechanism, including that crucial detail.
So the humans were able to achieve a deeper level of understanding.
Yeah, they were able to see the bigger picture.
That's pretty remarkable. So why do the researchers think there was this difference in performance? What sets the human scientists apart from the AI in this case?
Well, they concluded that the key difference lies in the cognitive strengths and limitations of each.
Okay.
Humans, they argue, might not be as good as AI at processing massive amounts of data all at once.
Right.
But we have something that AI currently lacks: curiosity and imagination.
That makes sense.
These are the qualities that allow us to break free from existing knowledge frameworks, to ask unconventional questions, and to be intrigued by those things that don't quite fit the pattern.
Yeah, it's that sense of wonder that drives us to explore and to make new discoveries.
Exactly. We're driven by this inherent desire to understand the world around us, even if we don't have all the answers yet.
Right.
Whereas ChatGPT-4, as impressive as it is still operating within a known hypothesis space. It's essentially limited by the vast but finite amount of data that it's been trained on.
So what might be an exciting new discovery for a human scientist might just be another data point for ChatGPT-4.
Yeah, that's a good way to put it. The bar for what constitutes a true unknown is much higher for an AI system like that.
That's a really profound insight. So while AI is incredibly powerful, it seems like it still has a long way to go before it can truly replicate the human spark of scientific creativity.
I think that's fair to say.
So where do we go from here? If current AI isn't quite ready to win a Nobel Prize on its own, what are some of the things that researchers are looking at to try to improve AI's ability to make new discoveries?
Well, the article mentions a few really interesting directions for future research.
Okay.
One area is something called neuromorphic systems. These are computer systems that are designed to mimic the structure and function of the human brain.
Wow, that's getting pretty close to the real thing.
Yeah, the idea is that by more closely mirroring how our brains work, we might be able to create AI systems that can learn and adapt in ways that are more similar to humans.
That's fascinating.
Another area they talk about is incorporating quantum computing into these systems.
Quantum computing.
Yeah, it's still very early days, but quantum computers have the potential to solve certain types of problems that are currently intractable for classical computers.
Right.
So the hope is that quantum computing could help us to create AI systems that are capable of a kind of machine intuition.
Machine intuition.
Yeah, the ability to make leaps of understanding that go beyond just processing data.
That would be a game changer.
It definitely would.
Okay, so neuromorphic systems and quantum computing. Any other promising avenues?
Yeah, one more that they highlight is the importance of continuous real-world learning.
Continuous real-world learning, what does that mean?
So instead of just training AI systems on a fixed data set, the idea is to create systems that can constantly learn and adapt from their ongoing experiences in the real world.
Oh, I see.
This would allow them to develop a much richer understanding of how the world actually works.
Okay.
And to potentially start identifying truly novel anomalies that might lead to new discoveries.
That makes sense. So it sounds like there's a lot of exciting work being done to try to bridge the gap between AI and human intelligence.
Definitely. And it'll be fascinating to see how these fields continue to evolve in the coming years.
Absolutely. So for our listener, to wrap up our deep dive into this fascinating article from Scientific Reports, what's the key takeaway here about the current state of AI in science?
I think the main point is this. While generative AI, like ChatGPT-4, is a really powerful tool for analyzing scientific data and building on what we already know, this experiment really suggests that the ability to make truly original, from-scratch scientific discoveries, those aha moments that come from curiosity and imagination, that's still a uniquely human trait.
At least for now.
Yeah, for now. Current AI is great at working within the boundaries of what we already know, but it's still not very good at venturing into the truly unknown without a little help from us humans.
Right. It still needs that human spark to really push the boundaries of scientific understanding. That's a pretty reassuring thought, I have to say.
Yeah, it is, in a way. But it also raises some really interesting questions about the future.
Yeah, for sure.
Like, what are the most important qualities that we need to cultivate in both human scientists and in AI to really advance our understanding of the world?
Yeah, great question.
And how can we create a future where humans and AI can work together in a way that leverages the strengths of both?
That's something for all of us to think about.
It is. It's not just about analyzing the world. It's about truly comprehending it in new and deeper ways.
Well said. And on that note, I think we'll wrap up our deep dive for today. But for our listener, here's a question to ponder. What do you think are the key ingredients for making those true breakthroughs in science, those moments of genuine insight and discovery?
Right.
Is it something that can ultimately be replicated in a machine? Or is it something uniquely human? Something to consider until our next deep dive.
I look forward to it.
Me too.